Yes, perfect. So now let me go into the power platform. Yes, let's start with the elephant in the room. What is big data? Anyone has any thoughts, anything that they know about what's big data?
It's like handling large data sets.
Okay. I'm sorry, who was it?
This is Mithilesh.
Hi, Mithilesh. So, okay, that's correct. Big data is like large data set. Understood. But how do you define large? Like 10 MB is large, 100 MB is large, 1 GB is large, 1 TB is large. What is large? Define large. You said large data set, but what is large?
Like it can goes up to terabytes.
Okay, so you're saying that any data set which is greater than 1 TB is a big data, is it?
No, like it varies. Like it can be GBs or TBs.
Then I would like you to define large. Like, is GB large? Is PB large? What is large? Because you said that big data is a large data set. And I'm sorry, I think in previous, whomsoever is new in this session, and I think I'm not sure if I've told this or not in my Power session earlier. But the reason I start with what my students know about a topic before I start teaching them topic is I want to know if they know something wrong or not. Because it's like it's important for me to first empty the glass and then fill it, rather than you have something already filled there, which might be even incorrect. And now I'm mixing water and oil together and trying to give you something good. That's not good. Hence, what I do is I always check what's there in the glass. And then once I know, either I empty it, if it's correct, I ask you to retain, and then I fill it with the rest of the concepts. So that's why I start the topic with this discussion session. And it's very important for me that what all you know about a topic, if you know at all. If you don't know, then it's well and good. It's really good for me because the class is already empty. I don't have to work upon that. But yeah, if it is not, then I would really like to know like what you all know, so that I can either help you out with clearing up the concept, or you can just forget those and then we can go ahead with it. Okay, so Mithilesh, yes, let's come back to you. So yes, big data is a large data set. Completely understand. You're saying it can be GB or TB, but then how would you say that a GB is a big data in some cases and a TB is a big data in some cases? On what basis? Are there any parameters, any conditions, anything?
I'm not that much clear on that part, so it just came into my mind and I just said, yeah.
Perfect. No worries. But that's true. It's partially true that it's a large data set. Thanks, Mithilesh. Anyone else?
I mean, the data that cannot be handled by a traditional program, actually, or something like that. Actually.
Good. That's new. I mean, you have added on to what Mithilesh said. Okay. So now, Raju, my question to you is, you're saying that a data which cannot be handled by a traditional program, a data set size. Now, the problem with that is, if a traditional program cannot handle a data set size, what I can do is, I can just give more compute power to that program and can handle that data set then. So let's say your traditional program was handling 1 GB of data set with, let's say, 1 GB of memory. But now you have 10 GB of data set and 1 GB of memory, and your traditional program is not able to handle. What I'll say that, Raju, I'm giving you 10 GB of memory, and now it can handle 10 GB of data set. Problem is solved. So it still hasn't become big data, right? Because now according to your definition, now your big data is able to, your traditional program is able to handle the data itself with the help of some additional computation power.
Right. Yeah. That kind of solves that the thing which I've described. Maybe it's like, handling the real-time data as well, I guess, actually. I mean, to extension to my point which I've mentioned, it's like, the data which it cannot handle because the pace at which it is coming, due to the pace at which it is coming, probably.
Okay. Got it. Raju, we'll discuss that in the later slides. Yes, anyone else? Akshay, Akshit, Rupesh, Vinayak.
I don't have any idea about big data, Shubham.
Good, no worries.
One thing we can say like big data are the technology that are not following the relational database concepts.
That's true, and that's partially true. Actually, we'll talk about that as well.
Okay.
That's partially true, Rupesh. So just keep that in mind. Hold on to that thought. Yes, hi Shailesh. Tell me.
Yeah, hi Shubham. To handle the large data set, we need more accuracy and efficiency.
Okay.
So maybe big data concept has been popped up.
I don't know. So when things of the accuracy, I mean, our 10 MB of file can be inaccurate. I mean, I can give you an inaccurate data set.
No, if we are performing any operations or if we are doing some analysis on the data set, so it may cause an issue in the traditional methods, what we will follow.
Okay. So can you just reinstate this definition? What is big data? Just to be on the same page. I mean, I understand what you told me, but I want to just frame it as a definition. Like, what would you, how would you define big data?
Like while handling big data is like more than terabytes and the petabytes. Accuracy and the efficiency. Okay. Again, question comes. So do you mean to say that big data is a data set which is in size more than 1 TB? It can be considered like in petabytes or the zettabytes. Okay. But you're talking in terms of the size itself, like it can be either peta, zeta, or something like that. And that's how we define, like on the basis of like these data set size, like either it is petabyte, zettabyte, or it could be terabyte. But you're not just sure about the which size it is. It's just that the size you're talking about. Correct? Yeah. Okay. Again, partially true. Not holistically. Yes, Prashant, your hand is raised.
Okay, just a guess, not sure, but maybe very big data on which we cannot directly apply any kind of logic, or we cannot draw any kind of inference, but we need to do some kind of filtering, and we can only draw inferences based on filtering and sampling and all that. I mean, just at a very high level, not sure.
Again, that's very close to the right definition.
Okay.
But partially true.
Okay.
Good try. I must say that. Okay, everyone. Thank you so much. Now I'll tell you like what exactly is big data and how you need to define big data. If someone asks you what is big data, you just need to ask them that, can you tell me what is the specs of your current or config of your current system? When they say that, then my config of my current system is, let's say 10 MB of RAM and 1 GB of, let's say, storage. Then for that guy, big data is 2 GB. If he has storage of 10 MB, then for that guy, big data is 11 MB. So essentially the key aspect to a big data is with respect to the system itself, which we are trying to define with. So if we cannot fit a data on a single machine, depending upon the size of that machine, then with respect to that machine, everything beyond its capacity is big data. If that machine size is 1 GB, let's say 1 GB storage it has, then for that machine, anything greater than 1 GB is big data. But that doesn't mean that for rest of the machine or rest of the world, it is big data. That's not.
I have one question here with respect to this point, actually.
Sure,
so when we say the data, right, I mean, is it the static data or the data, runtime data, actually? So that is not clear, actually.
Correct. Right now, we are talking about data at hand, data that we have. We are not talking about the data set that we will get in future. So when we talk about streaming data, Raju, streaming data involves data at hand. Basically, we call it data at rest and data in transit, the technical terms that we have. So right now,
you mean to say the data we should be able to store it either on on the on the database or on the RAM and then process it. That's
in a single machine. Yes, in a single machine. If you are able to store it, process it, and do anything with it on a single machine, then that's not big data. And anything when you're not able to do it on a single machine with respect to that machine, it becomes the big data. That doesn't mean that it will be big data for the rest of the world. It's just that it is big data for that particular machine.
Okay.
And the concept that you were talking about of streaming data, so we call these two terms called as they are known as in technical terms, data at rest and data at transit. So whenever we define big data, we always define in terms of data at rest. Data in transit, we do not take into consideration because, I mean, we are just estimating that this is the amount of data we'll get in this X amount of time. But we are not sure. It could be more, it could be less. We can just estimate, or we can have a probabilistic curve for that, but we don't have a final number. That's why we do not consider or take into account the data in transit or the streaming data. Mihir, you are on unmute for a while now. By any chance, do you want to speak something else? Like, do you want to say something?
Yeah, sir. So I will just say that big data might be large data sets, but at the same time, they can be unstructured, semi-structured, or structured data. And those might not be able to be processed by these traditional methods, but they might need some special algorithms for that.
You define the categories of the big data. Then again, you define how to process those big data, but you haven't defined the big data itself. just on the same page, Mihir. I mean, what you said is correct, but you haven't defined big data. Just to
Okay.
Any simple examples to just define what is big data? Any simple examples or
I'm sorry, Jesuri, are you saying something?
yeah, yes, sir. Any examples to consider what is big data, right?
Correct. So, yeah, example is as simple as, let's say I have, I mean, what is your specs? What is the configuration of your current system? Does it have 250 GB hard disk or 100 GB?
Yeah. Yes. Yes, I will. Okay. This is the scenario. My system having a 4 or 5 browser on the data of 1 TB. That means 2 TB of hard space. Now just go with this.
I'm sorry, your voice is echoing, Jesuri, somehow. I'm not able to understand it clearly.
Sorry.
Is it just for me, or I mean?
Now it's clear?
Yes, now it's better.
Yeah, okay.
Please, can you just repeat yourself once again?
Yeah, my device has 2 TB of hard disk, right? Then
Correct.
Okay.
And what is your RAM size?
RAM size 16.
16. Okay. So now, what do you think? Can your system process 2 TB of data?
No,
Why?
it's up to 2 TB. We can use it, but at last, if we use the full purpose, means it has some. We will face some problems, right?
Okay, so most of the time people start thinking, okay, I have 2 TB of hard disk, but the question that you are raising, right, that I have only 16 gigs of RAM. So what would happen is I won't be able to process that much of data with that kind of RAM. So that kind of question comes into our mind. First of all, always you can say, whenever you're talking about in terms of RAM and with respect to big data, always take 80% rule into consideration. 80% rule in the sense, whatever is your 16 gigs of RAM, let's say whatever is your RAM size, take only 80% of that RAM size available for your processing, for your big data processing. The rest 20% is generally taken up by the system itself to basically run their default task or the task in backend to just keep up the operating system up and running. Okay. So whatever is the 80% of 16 gigs of RAM, what is 80% of 16 gigs? It's around 14 GB. You will have something.
14 or 12.
Yeah, around 13, it's 13 point something, but yeah, let's take 14 as of now. You will have 14 gigs of RAM to process big data, right?
Yes.
Is what our calculation says. Now the problem or the challenge that you have in your mind, is that how would I process 2 TB of data with 14 gigs of RAM? So, Jasuria, I never asked you to process it at one go. Did I?
Okay.
Never, right? What you can do is you can create 14 GB batch of your 2 TB of data and process it one after the other in a serial fashion. And then your 2 TB of data will get processed eventually. So let's say 2048 divided by, you can say 14, that will be a number of batches. Then let's say one batch take 1 minute. So your total data processing will take whatever the number of batches you will get. That is 2048 divided by 14. And that's how you can process 2 TB of data on your machine. So it's not big data for your machine. But now the question comes, what is big data for your machine? I'm asking for 3 TB. Now that 1 TB of data is not existing in your machine itself. Now, how can you process that? The data that you do not have in your system, how would you process it? You won't be able to.
Yes.
That's big data with respect to the machine.
Okay.
Okay, that's
Yeah.
how we define generally. That's why Hadoop came into the picture, and I'll tell you why Hadoop was so famous. And I mean, still, why I'm teaching you Hadoop, so that you should be aware of what is Hadoop, from where we have grown and come here till. Because that actually it's important. It's not important to actually code on Hadoop as of today, but it's really important to know what was Hadoop, so that you know the general principle of big data computing.
Yeah, okay.
Okay, so we have three key points here on our screen. One says large, diverse sets of information that can grow at ever increasing rate. I think Raju, Mihir, and Shelja contributed to this particular point. Large, diverse set, ever increasing rate. Then the point which no one touched was the second point, and which I only described and said that that is the definition of big data, is the second point. It cannot be loaded on a single machine because of its size. Though increasing the memory of the system is an option, it is not an ideal choice. Reason being, of the first point, if the data is increasing at ever rate, you never know how much you have to increase, and you never know what is the capacity of your system till which you will be able to increase. Because I'm not sure how many of you are aware of this or not. It's not like you can, let's say, fit 1 TB of RAM on your traditional system. Each of our systems, motherboard and processor, has a maximum RAM limit that they can process or support. So it's not ideal that you just go on keep increasing RAM and memory option and compute power. Unless and until, yeah, if you change on that single motherboard, if you change the processor itself and then you change the RAM, yeah, that's certainly an option, but it's an expensive one. And again, you don't know till when you have to keep doing that. So that's not an ideal choice. So third point makes sense. Second point, we are seeing the definition itself. First point, why the first point, how the first point contributes or not contributes to the second point is, it says large. Large is not defined here. What is large? It is defined in the second point. Diverse set. But if we don't have diverse set, if I say that I have a RDBMS, but it is a 3 TB, but still it won't be able to process on JSurya system, right? Because JSurya system cannot keep that data in a single place, or I'd say it's not there on the storage space itself. That 1 TB of data is not there to process itself. Then how would JSurya process it? And I'm talking about just the relational data, nothing else. I'm not talking about variety of data set here, just the typical, you can say Excel file just of 3 TB. Again, it's not diverse, but still it's not, I mean, it will be a big data. And the third point that is there in the first point is the increasing rate. I'm not talking right now about the increasing rate. I'm just talking about a stagnant file of a fixed size 3 TB. So that's how first point is important, but it does not contribute that much to the second point. Second point is your key aspect while defining the big data. Now, the reason, basically, forget the second point now. Now let's talk about the first point in all. And let's move on to the next slide. Give me a sec. I'll bring all the points. Okay, that spelling is wrong. Just ignore that. This is not veracity, it is veracity. veracity, veracity. Now, the first point of the big data definition, the way it contributes to the big data in defining big data is because of these 5 key aspects. Then, because first of all, anyone has any question with respect to the first slide?
No, Subha.
Akshay said no. Okay, perfect. Akshay, I would like you to help me with this next question that I have. So you understood big data, right? And you said no. Now I'm going to give you a case where I'm saying that I give you unlimited storage, unlimited compute power. Now, how do you define big data? So as per our discussion so far, can anyone define big data now if I give you unlimited compute and unlimited storage?
Maybe,
She-
maybe
sorry?
based on the voluminous flow of the amount of like Raju said, the amount of
Yes,
flow based on that.
yes,
It can
that's true. That's true. Now the definition is what I mean. All the 3 points will come into the picture, defining the data, and it's not just limited to the second point. Because no one asked me this question, now I'm asking you this question: that what if someone gives you unlimited storage and unlimited space? Then how do you define it? So that's why all the 3 point contributes. When this kind of scenario you have unlimited storage, unlimited compute, all the 3 points in the previous slide contributes towards the definition of big data. Now, your first question should be that, I mean, that should come to your mind is, how can one get unlimited compute and unlimited storage? It's kind of impossible, right? Or is there a way? Yes, Akshay. Rupesh is also new. Yeah.
It is related to horizontal scaling, like adding server in parallel to our machine. Like the third point in the first
Yes.
slide was related to vertical scaling. Third point was related to vertical scaling, that it is hard to increase.
Correct.
And it is also not
It's
a good
about,
choice.
yes, it is horizontal scaling, related to horizontal scaling, but I'm not talking about the scaling your system itself. So I'm talking about, let's say, an organization which has just started and have 2 employees, and it's a startup that has just started. But what I'm telling you right now is that that guy also has unlimited compute and unlimited storage. Think from
No,
that
but
terms.
that
how
the
he will have it.
last, yeah, the infinite point or the last point we do not know, right? How much the data will be growing. So
Correct.
that
But no,
infinite,
question right now here is how one can get, even if there is not large corporation or large money involved at hand, but how one can get access to unlimited compute and unlimited storage. That is my question.
Distributed computing and all that.
Yes, but how? I mean, how you're getting access to that distributed computing? Because you need, let's say, 10 servers, but you don't have that kind of money. But what I'm telling you right now is that there is a way to get unlimited storage, unlimited compute without paying upfront and doing horizontal scaling, buying all of these servers. Sorry?
Pay
Cloud
as you
computing?
use. Yeah.
Yes. Who said it? Who said it?
By connecting commodity hardware or something like that?
No, that's definition of Hadoop. Sridevi, nice try. But yeah, Srikanth is right. Cloud computing. In today's world, the world that we are living in, cloud computing is accessible by anyone and everyone. You don't even need to pay. You get $200 for free. And as soon as you sign up on Azure, AWS, GCP, Alibaba, IBM, what else? I mean, any other cloud vendor also. You get access to unlimited compute, unlimited storage. I mean, it's just a click away. You can just slide that bar to 4,000, 5,000 terabyte, petabyte, zettabyte, whatever you want. It's as simple as that. And you don't need to pay unless and until you use that much space, because it is a pay as you go model. So even if you, in some of the cloud vendors, even if you take 4,000 gigs of space, like ask them for 4,000 gigs of space, they'll give you that, but they won't charge you until you fill, they will not charge you for 4,000 gigs unless and until you fill or use all the 4,000 gigs. If you use only 2,000 gigs out of that, they'll charge you only for that much. So cloud computing is our biggest enemy in case of big data, because now it is giving us unlimited cloud and unlimited compute, unlimited storage. But still, we need to define big data, right? Now all the 3 points will come into the picture, and our big data definition will have now these 5 key aspects while defining big data. So first aspect to defining big data is the velocity. Yes, Akshay, you are on mute. You want to say something?
no.
Okay, yeah. Just in case if anyone want to say anything, just please use the hand raise feature. I think Prashant used it correctly, just in case. So because I saw that Mihir was on for a while, but I was like, I observed that, then I call out. So sometimes actually I forget taking a look at chat. So it's better if you just raise hand, then I'll call out your name. You can unmute yourself and just tell us all your thoughts. Okay, yes, go ahead. Oh.
Yeah, hi Shubham. Shubham, I have also heard one term called GPU for improvising the computing of
that is
graphical
processing unit. Graphical processing unit. So there are 3 main things to, I mean, when you are there, so since you are there in data science world, data engineering world, there will be 3 things that you need to take into consideration. That is, one is RAM, another one is CPU, and third one is GPU. when you talk about big data processing, CPU and RAM will do away. But when you apply, let's say data science algorithm, machine learning algorithms, AI, ML algorithms on that data set, you need GPU power as well, because GPU enhances or optimizes the processing of ML algorithm or ML task or AI task on top of that big data. Traditional CPU and RAM are not that good in that sense to apply those ML task or perform ML task on that kind of data set. So while we are talking about big data, CPU and RAM would do away. But when you talk about applying data science techniques or data engineering techniques for that matter also on that big data, GPU might be involved. Mostly you can say ML, AI concepts when you need to apply on big data, you need GPU power, and that you need in the sense that will perform the ML AI task in lesser time as compared to traditional CPU and RAM. Those tasks can be done by the CPU, traditional CPU and RAM, but it will take more time without GPU help. If GPU is there, it will be done in a much lesser time. GPU is what we call as graphical processing unit. Traditionally, GPUs were always used in the sense of gaming and video editing softwares. They only leveraged GPUs for rendering the number of frames and using GPU compute power to make the games better or make the games, you can say, their FPS, frame per second processing better. But what NVIDIA and Intel saw this particular, you can say, opportunity, and what they leveraged, or how they leveraged was they used GPU for big data processing to apply these ML AI tasks. If we have the compute, I mean, extra compute besides CPU and RAM, we have GPU also, why shouldn't we use it? And then they found it, okay, GPU are more you can say optimal to perform ML AI tasks as compared to CPU because of their traditional architecture, and the reason they don't have to run or take, you can say, burden of the backend running task of an OS, because CPU runs your whole OS related task, GPU does nothing related to it. So GPU has much more capability in terms of performing those tasks. Rupesh saying, is GPU more compatible on Linux? GPU is there. I mean, GPU is a hardware thing, and on top of that hardware, you can install any OS. Now, as far as is it more compatible on Linux, Mac platform, I'd not say that. It is very much compatible with Windows, and actually it is compatible with all the OSs. It's just that how do you use or which software do you use on that particular platform. So let's say these video editing software are nowadays available on all the three major OS platform, that is Linux, Mac, and Windows. So GPU can be used in all of these three platforms. If you have not heard of, AMD has its own GPU, NVIDIA has its own GPU, Intel has its own GPU. These are the three main contenders for GPU world, where NVIDIA and AMD are the main ones. Intel is a sidekick. And AMD is like ruling right now in terms of GPU. But yeah, NVIDIA is the one that is preferred for ML AI tasks because NVIDIA has its own library to optimize its GPU. AMD hasn't invested that much in that sense. AMD is still traditionally used for gaming and video editing. So that's that. Anyone has any other questions related to GPU or anything of these fundamental key terms?